Today, we're talking about PyTorch. Most people know it as the tool data scientists use to build AI models, but it's actually the most important bridge in technology right now. At Red Hat, we're focused on PyTorch because for AI to be useful, it has to be more than an experiment. Joining me to explore this is Steve Pousty, a principal AI community architect in the Red Hat Open Source AI Program Office. Welcome to Technically Speaking, where we explore how open source is shaping the future of technology. I'm your host, Chris Wright. Hey, Steve, it's great to have you here today.
Thanks, Chris. I love being here. Go Slugs!
Go banana slugs, absolutely. So before we really just jump in, let's capture the big picture.
Okay.
Now, most people are going to put Red Hat in the camp of the Linux company or the Kubernetes company or the Ansible company, those core technologies. So here we're talking about PyTorch. What about PyTorch? Why all the effort in this space? Tell me from your point of view, what is important about PyTorch?
PyTorch has become the de facto standard for the underlying library under almost all of this AI work, and up and down the stack and up and across all sorts of devices. My feeling about what Red Hat is doing from being on the inside is we're repeating our story again in a good way, which is, nobody wanted just a Linux kernel. People wanted a Linux distribution. Then nobody really wanted a Kubernetes by a bare metal Kubernetes. They wanted a Kubernetes distribution. And what's coming up in this AI world is, sure, there are some people who just want PyTorch at a university or at a research facility or some of the really big places. But for most people, they want an AI distribution. Give me some opinionated choices that I can swap around if I want. But I want a distribution that you're going to back up for me and give stuff. And we've always wanted to speak from authority as Red Hat. So we had people as kernel committers. We have a lot of people on all the different C and CF projects. And so we're repeating that story again here, which is you can't really have the new AI world without PyTorch, and we can't really offer a good supported distribution without being involved in PyTorch.
Yeah, I often draw the analogy. It's a little unfortunate because there's a collision of terminology,
Right.
but I often draw the analogy to the Linux kernel and PyTorch being that layer that sits between the hardware and that higher level runtime, whether you're focused on training libraries or whether you're focused on serving models. There's something that's in the middle that's doing all of the complicated, supporting all the complicated tensor math and offloading that into the accelerators.
I mean, I think it's actually a really good analogy for how I think of how it is. The reason I think it's a good analogy is for most, I know we said most before, but we can say most again here, which is like for most people who aren't hardcore data scientists or hardcore like data algorithm or AI people, like low level AI people, PyTorch forms the foundation of the ecosystem that they're working with and the way they interact with the whole system in the same way that the Linux kernel does, right? Like I know there's a Linux kernel on my desktop machine. I never really do much with it, but I know that everybody else is relying on the things that I use that everybody else makes. They're relying on that kernel to do the right thing so that they don't have to do that stuff. And that's what PyTorch does. I mean, it really is the kernel for the modern AI. When I interact with data scientists and even the low level people, the OS is an abstraction to them. Like they don't think on that level really at all. They're not. I know a lot of our systems administrator customers and all that stuff, and that part of our community thinks at that level, but this community doesn't really think at that level. They're starting with an OS that says it kind of as a given. And so it's in the same way that a lot of our systems administrators, like the x86 platform is just a given. Like that hardware architecture is just a given, and then we put a kernel on top. For them, there's an OS,
right?
And I'm building stuff, and that's a given. And now I'm building stuff to optimize on top of that, right? It's just they've just moved up a level. I don't know if that's making it too simplistic, but they just work at a different level. And for them, PyTorch is the kernel. Like it is the kernel.
We've established this sense of there's a center of gravity around a key technology project. That's PyTorch. It builds that foundational layer for an ecosystem to develop around. Well, why don't we just walk through PyTorch? What's inside? How do we look at the foundation of this stack? We talked a little bit about hardware. There's the higher level pieces of training and inference. Let's talk about PyTorch.
Okay, so like we said, PyTorch, I know everybody says this, but PyTorch really is an abstraction layer, right? In this for most people. And it's the best way for people to think about it because it's a library, right? Like is what it is. And libraries are abstractions. Like I don't want to write that sorting algorithm. I just want to say sort and you sort for me. I don't have to think about it. So what's the pieces of it though? That's what you're asking about. So the pieces of it are, there's the core tensor libraries, which do all the calculations. But there's more to it than that. So I don't deal at that level as much, low level, because I'm one of those people who's like, no, I just want to make the call into, Hugging Face transformers and have it do the work for me. There's the pieces inside of PyTorch are the piece you write your code in Python, but then as part of the process, it actually compiles. It's like a DSL. You're just using Python as the DSL to create an execution graph for how it's going to do all the tensor operations. And usually what people are doing with the tensor operations for most AI ML stuff is some sort of gradient descent, or that's a primary work
Right.
topic that people use it for a lot, because that's hard it's all matrix calculations. And this is like optimizing all the algorithms that do all that matrix calculations. And the compile part is actually saying, okay, well, given that you're doing these matrix operations like this, I'm going to optimize that flow, right? And be efficient about memory transfers and all that kind of stuff. And so there's that compile phase. And then once that's done, then there is your running code that does the gradient descent and does all those matrix operations over time in loops.
Yeah, no, I think it's useful. I mean, I'm a math geek, and so thinking about the large number of parameters in these math problems and the complicated associated linear algebra and those topological surfaces that are created that you can't even imagine anymore once we get past 3 dimensions, and then understanding gradient descent in that context. I mean, that is the hardcore math that's happening inside the various Torch libraries. And you got compile. Okay, there's one primitive. You've got serve, another primitive that we care quite a bit about. So, and in any of these contexts, it is about the math, and in that math, it's optimizations, mathematical operation optimizations, and then how do you get it into the hardware?
Right, exactly. It's not like, oh, I can take forever to find the optimum, right? Like we all have things to do and we want to get answers. And so you're trying to find the fastest way to get to the best approximation of the maximum or minimum that you can get, right? And so all the parts of there's different parts of the PyTorch ecosystem. Like there's other pieces that are dealing like actually hard compiling and minimizing the size of the weights and optimizing the speed of the weights, maybe at the sacrifice for being on device, right? There's a big effort within the PyTorch community, particularly from the embedded manufacturers, to get a version of PyTorch, or to allow PyTorch to produce an asset that's smaller and optimized for on a phone or on a sensor sitting off somewhere, and still be able to run it and get the pieces out of it that you want, right? So there's a lot going on. It's not just one, oh, here's one library. It's like, no, there's people, and they specialize within each of those areas. Like one of the big areas Red Hat has started contributing to, because it's important for vLLM and inference serving, which is really important for us, or serving models, is compile, right? Because PyTorch vLLM compiles that model to do optimal serving, right? And so we want to help with the compile, but we're also working on another project through PyTorch called OpenReg, right? Because the number of hardware accelerators is proliferating. Like when PyTorch was first built, it was basically NVIDIA and that was it. And so it wasn't hard for them to build a CI/CD chain and test suite because it's one hardware accelerator, and that was great. But now that they're in a foundation and it's they want to encourage an open ecosystem, you want to make it easy for new hardware accelerators to take advantage of PyTorch.
Well, interesting. You bring in OpenReg, and for me, it draws a couple of ideas to the surface. One is the hardware proliferation that you touched on, and early days we had fewer choices. Um, it's a bit of an exaggeration, but it feels like every day there's a new accelerator. Certainly, there are more choices in hardware and more coming that just are displaying this proliferation, which also includes traditional CPUs, and CPUs get new instructions, and so it's a big diverse community at that hardware layer. This way of onboarding into the community and then having a consistent way to verify that your accelerator is working properly with PyTorch is awesome. It hints at the value of recognizing, I'll say like at the industry level, recognizing industry de facto standard technology building blocks, and then creating some governance connected to that. In this case, PyTorch has moved into the PyTorch Foundation. There are other projects within the PyTorch Foundation, as you highlighted. What do you think about that sort of the governance and the the idea of bringing these critical industry standard projects into a common playing field?
Okay, well, so cards on the table. I'm open source from way back, so
Okay.
let's just make that clear.
You and me both.
Yeah, exactly. I mean, I think some of it's from my academic background, like I have a PhD, and so it was always like, well, you publish and you share your data. That's just what you do, right? So I think it's key. I think actually PyTorch has grown and became partly that de facto standard because of their ability not just to be open source, but to move into a foundation, right? There's been a lot of controversy, let's just say, in the last several years about what it means to be open source and what kind of license you can have. And customers or other people who consume open source looking at it and saying, well, that's nice that it's open source, but how do I know you're not going to just turn around and close source it, or you're going to take it in a direction? Like, I want to have some sort of assurances. And I think the best way to do this is something like putting it in a foundation. So just one quick clarification though, just for people who aren't as familiar. There's PyTorch, the project, which is an open source project. Then there's the PyTorch Foundation, which actually has multiple projects, including PyTorch inside of it. It's kind of like as if there's the Kubernetes project, and then rather than being CNCF, it was the Kubernetes Foundation, just so that people understand that.
Right.
And then within PyTorch, there is formally an ecosystem, and that is for open source affiliated projects. They have to be open source and have certain governance rules, and they use PyTorch, but they're not managed by the foundation, right? They don't have as strict a criteria to become part of the ecosystem. It's much easier to become part of the ecosystem. To be a foundation project, it's like really the strict criteria and governance and all this other stuff.
So we touched on this, the importance of governance. I'll put it at an industry level, recognizing where we have these critical industry building blocks, and creating an ecosystem around an efficiency of building these foundational building blocks. OpenReg as an example of a project within the PyTorch Foundation that's helping onboard the hardware proliferation that we touched on. What are some of the other key projects that are important to highlight in the PyTorch Foundation?
Okay, so there's like a lot of different areas I'm excited about in the PyTorch ecosystem. I'm going to try to name some of them, and then I'll go in depth on a couple of them, because there's only so many hours in a day. Too many. So two that I'm excited about, and one we may go into a little bit more later, but reinforcement learning I think is really important. I keep hearing it all over the place, and I know what it's doing, and it's good stuff. Agents, of course. PyTorch, you said, hey, I'm dealing with foundational stuff. And it actually turns out PyTorch is critical for agents as well, just not in your face kind of critical. The others I want to dig in on are, one is distributed computing, distributed solving, distributed serving, distributed tasks within AI/ML. The other would be kernel optimizations, like actually getting the most bang for your buck out of the PyTorch kernel for you once you start to scale or have particular use cases. And scale could be size or time, like you really want to get much faster. And then the last area is inferencing. So in the distributed, in terms of what came to PyTorch, the Anyscale donated Ray to PyTorch last year. The actual foundation donated to the foundation, and Ray is really great at distributing things. So there's like Ray serving, which is great at distributed serving. There's Ray tuning or Ray data. These are ways for distributing data flows, because distributed really matters here, because the type of problems, remember, we're doing matrix calculations, and these matrix calculations are really amenable to partitioning and horizontal scaling, parallelization, right? They really are amenable to it. And while they're really amenable, like they're perfect problems for it, it's tricky. So it's not an easy thing to solve. You're like, it's great, but it's hard to do, because if you think about it, like moving model weights around and moving all that data around in the right way can get you. And then in terms of kernel optimizations, one of the places Red Hat's been really excited is Helion. And I think Helion allows you to almost like work in a domain-specific language or a domain-specific DSL to actually optimize your kernel easier, make that process easier to optimize kernel. And you're like, well, why do I need to optimize a kernel? And it actually turns out when you're just doing your own work on your own machine, it doesn't really matter that much, because you're just playing around. But as you move to scale, chopping 30% off of your execution time or the number of instructions because you optimize that kernel specific to your application rather than just being some generic kernel, it means a lot, right? And then, as we said before, like inference is really big. And in that case, what we have, and that was one of the early donations to the PyTorch Foundation, was vLLM. So it came out of Berkeley Skylab. It was donated to the PyTorch Foundation. Red Hat has been intimately involved with it, I think even before it was donated, or maybe right when it was donated, or somewhere around there. Most companies are not in the business of making foundational frontier models, but they want to consume them and serve them up to their end users in an efficient way. And it's really interesting to see the things that vLLM bakes and takes advantage of in PyTorch, or like bakes into the way it does attention and all these things to optimize that serving experience. And, inference is so important, and VLM is so important that just recently llm-d was announced. This is a Kubernetes-native way of distributing inference. And vLLM is the engine inside of that, right? But it's such an important piece that even the CNCF has something that's like, this was donated to the CNCF. And even in CNCF, they know that model serving is an important area and they need to pay attention to it. So again, the three areas I wanted to draw into focus were distributed computing, just like the distributed part, the kernel optimization for once you really start moving to scale, and then the inference, because that's primarily what you want to do inside your company. That's what you're getting asked to do by your boss, probably.
Yeah, that's perfect. I appreciate that. It really draws out the key aspects of the breadth of the PyTorch Foundation, which in your words is almost like the CNCF of the AI ML world. So a really important center of gravity.
Yeah, I mean, that is, I think, going to the PyTorch committee meetings and being in part of that and seeing where they're going with it, I think that is what they're aspiring to be, right? I think if you watch the recent PyTorch conferences that have been happening, they started off relatively small, but like even just this year, PyTorch Conference EU went from PyTorch Conference EU Day or PyTorch Day EU to now it's a full 2-day conference. They had it oversubscribed. Like, it was really well done. And I think what they're doing is trying to move more towards the KubeCon. They want PyTorches to become the KubeCons of the AI/ML world, right? And I think that's important. One thing that's important about it is KubeCon is a broad level playing field. It's the biggest one that's like a broad level playing field, as opposed to like AWS reInvent. That's a huge conference, but it's AWS specific. And I think that's the role that PyTorch Conf could play. GTC is huge, right? When NVIDIA does their show, it's huge and everybody pays attention, but it's NVIDIA. There's not this big event that's focused on enterprise use cases or enterprise users that actually is like a KubeCon.
Neutral.
Yeah. And so we need something like that. And I think they're moving in that direction. I think it's really great.
All right. So we've got like big picture. We got all the understanding of the project PyTorch, the foundation PyTorch, the ecosystem PyTorch, all the work that's happening in this space. We touched briefly earlier on agents. Hard to have a conversation today without bringing agents into the foreground. So you're spending all of your time in the PyTorch community. What's the agent connection with PyTorch?
So for me, agents is the culmination of where the AI/ML space, or at least we're getting close to where the AI/ML space really becomes useful to people, right? In the same way that like Linux was good for serving things, but it's the applications finally when it was on top that I was like, oh, now I can do stuff with it. And so, right, like because I didn't want to write low-level kernel stuff. So what's happening here is agents are really like some application code with some like AI/ML code underneath of that application, and the application's coordinating all these different calls. And so you can't really have agents without the models underneath. And you, again, like we said, PyTorch is foundational to those models, right? And then, but we add in these other wrinkles on top of that, which is, well, now that you've built an agentic system, is it actually useful? Is it answering questions in the way you want? So there's this whole eval framework. And in a lot of the eval frameworks that we look at, and I'm sure one's going to probably be moving into the foundation soon enough. This is not me. I don't work at that pay grade, but I'm just reading the tea leaves. That's what I predict. There's got to be some sort of eval coming in and they use PyTorch under the hoods. It could be that they're actually directly using PyTorch, or maybe they're using llm as a judge in the evaluation, and that model's using PyTorch. Like it is, PyTorch again is like that base bedrock or the foundational layer. Like think of it in your garden. It's the bottom of your garden. It's everything growing up out of it. And it is a good fertilizer for growing a great ecosystem around all those other things. And without good soil, you don't have a good garden, no matter how hard you try. And I think PyTorch is acting like a great garden base layer. That's how I feel about it. Like you can't have agents without it. There's just no way. So,
well, Steve, it's been awesome to learn more about the PyTorch community. Really appreciate your time, and thanks for helping us dig in and understand what's going on in this important community.
Thanks. Anytime you want me to talk about PyTorch, AI/ML, it's always a great time, especially with you. Go Slokes.
Thanks, Steve.
Thanks, Chris.
The takeaway here is that PyTorch is the underpinning of the modern AI stack. At Red Hat, we're focused on helping make PyTorch enterprise ready. This means it's stable, tested, and hardware agnostic. With inference projects like vLLM in this ecosystem, we can create a path for enterprises to move AI out of the lab and into production safely. Thanks for joining the conversation. I'm Chris Wright, and I can't wait to see what we explore next on Technically Speaking.